All right, so continuing with triangles and some special relationships within those, we're looking at isosceles and equilateral triangles now. And our essential question is, what are some special relationships among angles and sides in isosceles and equilateral triangles? So isosceles triangle theorem states if two sides of a triangle are congruent, then the two angles opposite the sides are congruent. So here we are given that AB is congruent to AC, and we want to prove that angle B is congruent to angle C. So that's our goal. So here we have that BA is congruent to CA, that is given. We have angle A is congruent to angle A. And our reason for that is reflexive property of congruence. So angle A is reflected onto itself, so therefore they're congruent. And then CA is congruent to BA, so that's symmetric property of equality. Doesn't matter which order you write it in, it's still true. So then we know that triangle BAC is congruent to CAB. If we remember back to our triangle congruencies, we now have side, angle, side. Congruency there. And then because of that, we have angle B, which is now congruent to angle C. And the reason for that is what is shorthand Cpctc, which stands for corresponding parts of congruent triangles are congruent. But ain't nobody got time for that, so we just write Cpctc. That's how the cool kids do it. And all it's stating is, since we just proved that BAC is congruent to CAB, that those triangles are congruent because we reflected them, that everything else in that triangle also has to be congruent. All right, so let's look at, from there we want to complete the statement of the converse of the isosceles triangle theorem. So the statement up here is if two sides of a triangle are congruent, then the two sides opposite the sides are congruent. So I want you to go ahead and write the converse of that, calling someone to share that out with us. And then we're going to work on the proof here. So now we are given that two angles are congruent, and we want to prove that the two sides are congruent there. So we start with angle ABC is congruent to ACB. That's given. All we did is we were just more specific with it. And then reflexive property gives us BC is congruent ACB is congruent to ABC. And then from there we get triangle ABC is congruent to angle or triangle ACB. CB, and that is angle, side angle now. So let me label it, because we have that segment there that was congruent. So we have angle, side angle now. And then AB is congruent to AC by the very cool Cpctc. All right, moving on. So now we've dealt with isosceles triangles, so let's deal with equilateral triangles. So an equilateral triangle is a triangle with 3 congruent sides. An equal angular triangle is a triangle with 3 congruent angles. So our equilateral triangle theorem states if a triangle is equilateral, then it is equal angular. So what we want to do is prove those. And this time we have a paragraph proof that we're going to work through. So here we are given that AB is congruent to AC, which is congruent to BC. And we want to prove that angle A is congruent to angle B, which is congruent to angle C. So given that AB is congruent to AC, we know AB, AC. We know that angle B is congruent to angle C. And that was what we just proved. So that is our isosceles theorem, triangle theorem. And also known that angle A is congruent to angle B. By the isosceles triangle theorem, since we can state that AC is congruent to BC. So AC here is congruent to BC. So we're just rotating our isosceles triangle around. And therefore angle A is congruent to angle C by substitution. And finally, angle A is congruent to angle B, which is congruent to angle C by the transitive property of congruence. Now we could have proven the last angle A is congruent to angle C by isosceles as well, just a different way that we can go about it. All right, continuing on with the converse. So now if a triangle is equal angular, then it is equilateral. So we're given our angles this time. Angle A is congruent to angle B, which is congruent to angle C. And we want to prove our sides. AB is congruent to AC, congruent to BC. Because angle B is congruent to angle C, so we're dealing with those there. We then know that AB is congruent to AC. By the converse of the isosceles triangle theorem. And then AC is congruent to BC by the converse of the isosceles triangle theorem because angle A is congruent to angle B. So again, talking about AC and BC because angle A and B are congruent. Again, just working our way around. And thus by transitive property of congruence, we can then state that AB is congruent to BC. Therefore, AB is congruent to AC, which is congruent to BC. All right, so as we look at problem here, said Katie is stitching the center inlay onto a banner that she created to represent her new tutorial service. It is an equilateral triangle with the following dimensions in centimeters. What is the length of each side of the triangle? Now, since we know that it is equilateral, that tells us that all the sides are the same. So then we could write 6x minus 5 is equal to 4x plus 7. And solving from there, I can subtract 4x over. It gives me 2x. And then add 5. Which gives me 12 divided by 2. And x equals 6. But we don't want to solve for x, we want to solve for our side lengths. So then I'm going to substitute it in. So 6 in for x. 4 times 6 is 24. Plus 7 is 31 centimeters in this case. And then since we know it's an equilateral, we don't have to find or substitute 6 in for x for 6x minus 5 because we know that one's 31 as well. So all the sides of the triangle are 31 centimeters. All right, go ahead and solve for that problem there. Number 4, we want to find the measure of angle T based on what you know there. So that's all the information you're given, but that is all that you need. And then elaborate. Consider the vertex and base angles of an isosceles triangle. Can they be right angles? Can they be obtuse? Explain. Okay, so remember, right angle is 90 degrees. Obtuse is an angle greater than 90 but less than 180. So jot down your ideas for that, and we'll share that out as a class. And an essential question check-in. Discuss how the sides of an isosceles triangle relate to its angles.